Midas NFX Lecture 9 CFD Analysis Mixing of Hot and Cold Water. Open a new file. Give it a name. Import geometry. So we finish with the first step, the geometry. The second step will be the material. And we'll load the material. You have to be careful that in Midas, the solid materials and fluid dynamics, computational dynamics materials are separated. So even if you are choosing solid materials in CFD analysis, you have to choose it here instead of here. Okay, I'll choose water, and I'll choose 50 degrees C water, and this is closer to the average temperature. And I'll connect the geometry with the material. And also in this property section, you have to define the property here in CFD 3D, and this is the geometry, and connect it to the fresh water. So we have finished with the second step. The second step was loading a fluid material and connect the material with the geometry. Step 3, meshing. For the meshing, I'll choose this geometry and mesh it to half of the default mesh size. Okay. So we have finished with the step 3. For step 4, first of all, I'll give it a temperature for boundary conditions. And in CFD, we have heat transfer boundary conditions. I'll define hot water coming from the left, 90 degrees. And cool water coming from the right, for example, 25 degrees. And this is the heat transfer boundary conditions. And then for the flow boundary conditions, I'll choose this surface and this surface as the inlet surface. And I'll choose mass flow rate of 10 grams per second. And for outlet, I'll choose the default, accept the default atmosphere pressure. And now for the walls, I'll choose all boundaries as walls except for the inlet and outlet. And I'll define the walls to be a distance of 1 millimeter of distance to be totally no slip. Okay, so now we have finished with step 4. So if you are interested in knowing that the goal to be optimized or converged at some point, for example, if you choose this point or some other points to measure the temperatures, so you can define goals or monitors as the result monitor. So the software will calculate until the number enters a certain predefined accuracy, or it will converge to a certain numerical value. So now we have finished with the step 4. For step 5, we use steady state CFD analysis and edit. And for the steady state condition, we only have to click on the fluid heat transfer checkbox, and I'll leave it to the present default value of 1000 steps. And also for the output control, I'll accept the default condition. generally, before we run the solution, generally we will save the procedure. So we are going to enter step 5, perform the analysis. And as I said in the last lecture, that there's a very interesting and powerful way of looking at the result in Midas, in that you can open the result file during calculation. So that is the very powerful, very interesting feature for Midas. But at the present time, the iteration is only at the beginning. So even if I open the result file, it is nothing there. Nothing was there because it is only a beginning of calculation. So you can see that the velocity has some values and others are not calculated yet. So I can open the result file for the later development, and then I can see the more recent values of the result. So the software is calculating the result. So I'll stop recording and let the software calculate the iterations. I'll pause. After some calculations, we can see that the numerical values are more stabilized. So we can load the result file again, and we can see the pressure distribution, the velocity distribution, the pressure drop, and also the temperature. And although it is on the early stages of iterations, we can see that the temperature at outlet, for example, we can probe the numerical values at the left hand side. It will be closer to 90 degrees. For the right hand side, it is closer to 20 degrees C. And we can also see that the numerical value is approaching the about 47 degrees at the center, but we still feel that the left hand side, your left hand will be very hot and the right hand will be cold. And so this is the lecture 9. I'm not going to wait until the termination of iteration. However, you can see that the pressure drop distribution of the system, and also you can see that the velocity and also the temperature distribution of the water. This is something like we have hot water coming and cold water coming, and then we wash our hands. So very often we will define some structure to it, so that for the outlet to be more uniformly distributed water, the temperature will be more uniform at the outlet. So we can design some of the structures inside this tube, so we can get a more uniformly distributed temperature distribution. So this is lecture 9.